follow. Okay, so what three things about this graph make sense after investigating the equation?
The y-intercept is the same as the constant.
Very good. The y-intercept is the same as the constant. That's always a great thing to look for right off the bat. What else makes perfect sense just by looking at it?
It's a positive.
It's positive because lead coefficient is pointing up, yeah. And it has a degree of 4. How many zeros does it have? 4. So that makes sense. Okay, so since we mentioned the roots, it asks right here, what conclusion can we draw about the 4 roots just by looking? We're not going to do anything to the equation yet. We're not going to...
They are negative and positive.
I have 2 negatives, 2 positives. I do have one of them is an integer. So before, and we'll get into this in just a minute, that means because that 1 that we can clearly see, the 3 is an integer, that means it is rational because it has great behavior. These others, I'm not sure yet. This one right here, well, I don't know, you really can't tell on the other 3 because I have no idea what kind of fractions those might be. If they come out to be a third, that would be rational. If they come out to be square root of 2, that would be irrational, and I don't know that yet. But I do know I can see all 4 of them on the graph, which means they are at least all 4 real. Because if they were imaginary, you couldn't graph them, so you wouldn't be able to see them. Okay, so we are going to make a list, what we learned yesterday, of our possible rational roots. So remember that our PRR, possible rational roots, that comes from factors of the constant over factors of the lead coefficient. So let's see, that's going to be, my constant is 9, so that'd be positive and negative 1, positive and negative 3, positive and negative 9. My lead coefficient is 3, so that just has 2 factors, 1 and 3. Okay, so I'm going to make my list.
This is a really short list.
It will be short. So positive and negative 1, 1/3, 3. That is a short list. I like it. From this list, which roots appear to be roots on the graph above? And then it says, perform synthetic division to verify that they are in fact roots. One of them for sure we can see is 3. So let's synthetically divide with that one. Okay, I am not positive, but this one right here, I think it might be negative 1/3. This one right here. So let's just try it and see. And I'm going to just use the coefficients that I just got, just because it'll be easier. So negative 1/3. And I'm going to use 3, 1, negative 5, negative 3. I'm pretty sure that's going to work. actually are zeros. So x equals 3 and x equals negative 1/3 are roots, or zeros. Okay, so I divided a 4th degree polynomial twice because I didn't start over. So when I divided it first, it was quartic, and that would make this cubic, and then I used those, so it was cubic, and when I divided that makes this quadratic. So my remaining polynomial is quadratic. That would make it 3x squared minus 9 equals 0, because the linear value is 0. You could write it 0x if you wanted to, just to make sure you're not confused. So now I can just solve for x. So I'm going to add 9 to both sides. Divide by 3. So I get x squared equals 3. Take the square root. Don't forget, when you take the square root, there are 2 answers. So x equals both positive and negative square root 3, which is irrational. So altogether, my final roots of what was this, h of x, one-third, 3, negative square root 3, and positive square root 3. All right, so on the next page, they gave us a new function at the top. And what sort of function is that? It's quartic, but when you look at the graph, what does it look like it is? It looks quadratic. If all they gave us was the picture, we would assume it's quadratic. But they actually gave us the function, so we know it has a degree of 4. So what do you notice about this graph that does not make sense?
They're not for.
Maybe.
It looks cool.
It looks quadratic, right? The degree of f of x is 4. But the graph looks quadratic.
It appears to be 2 roots when there should be 4.
Exactly. It appears like there's only 2 roots. And I know they're not double roots. How do I know they're not double roots? Because it passes through. So they're not double roots. So if that's the case, what conclusion can I draw about the 4 roots?
One of them, but
2 of them are imaginary.
Very good. 2 of them are imaginary. So so we want to do our list of possible rational roots again. So factors of the constant over factors of the lead coefficient. This will be short also. Because 4 only has 3 factors, 1, 2, and 4, and 2 only has 2. So my list, 1 over 1 is a 1, and 1 over 2. 2 over 1. Okay, so from my list, obviously 1 is one of them. So I can synthetically divide with that. And then if I'm looking at my graph, it looks to me like that's pretty much in the middle. So I'm going to go with -1/2. And I'm going to use what I was left with here. Okay, so again, we started quartic, which means when we did this division, that got us down to cubic, and then this division gets us down to quadratic. So that would be 2x squared plus 0x, but you don't have to do that, plus 8. So when I'm solving for x, I moved to the 8 over and it became negative. Divide by 2, and so I got x squared equals -4. Take this square root, don't forget there's positive and negative answers. So x equals positive and negative 2i. So f of x has roots x equals -1/2, 1, -2i, and +2i. Okay, so now we've learned a lot of different things, because if you think back, we started this week with Descartes' rule, counting sign changes, and figuring out how many positive and negatives we were going to have, and how many were going to be 0. Now we're looking at imaginaries and irrationals. So we got to put all that together, because it's all about finding all of the roots to a function. Okay, so they've given us this quartic function, and they want us to answer these questions. First thing they want us to do is back to Descartes' rule. They want us to make a possible chart of positives, negatives, zeros, and imaginaries. So what about zeros?
None.
Zeros that are 0. None, because you have a constant at the end. Okay, so when I make my little chart, positive, negative, 0, and imaginary, I know already that this is 0. I don't have any. You can't have any because it doesn't have anything at the end. I'm going to count positive sign changes first. Same. 1. Which means 1. Because you can't, remember, you subtract multiples of 2, and I can't subtract 2 from 1. Well, you can, but you get a negative number, and that doesn't help you. So there will be 1 positive root. So now I've got to figure out how many negatives there are going to be. So plug in negative x. Simplify, count sign changes. 1, 2, 3. Okay, so there's going to be 3 or 1 negative roots. So I know that I have to have a 3 and a 1. So if I put a 3 here with the 1 positive, will I have any imaginaries? No. But I have 1 positive. If I have 1 negative, I know I have 0 zeros. How many imaginary would you have?
2.
Okay. Now, use your graphing calculator. And let's look. once you get it, go ahead and sketch it. It looks, that's really all I see. Of course, it's, bless you, it's not really in the window all that great, but I can clearly see it only crosses and it goes straight through twice. So it looks kind of like that. What conclusion can I make about the four roots?
How does somebody do imagine?
Yeah, so of my possibilities up here, it looks like it's this last one. I have one positive, one negative, and two imaginaries. All right, so now make your possible, your PRR list, possible rational roots. So factors of 10. Ugh, this list is long. Yuck. Yeah, it's gross.
This is where I get lost.
I tell you what, I mean, they asked for the whole list, and more than likely on a quiz or a test, they're gonna ask for the whole list. But you really don't need the whole list, because looking at them, what do you know for sure about both of them?
It's less than.
It's less than 1. So it's gonna be a fraction. So you don't really need any of the whole numbers or any of the numbers that are gonna be bigger than 1. So
we can stop at 1 point.
well, no, I mean, you can't stop because
Because there could be.
there's other fractions, like 2/3 is a fraction. And 5/6 is a fraction, or 5/12 is a fraction, but you do know it's gonna be a fraction. That definitely narrows things down when you start like, trying to figure out what it is. Okay, that's a long list. That's a lot to choose
Okay,
from.
so you know how you stopped at 2/3? Why did you stop at 2/3? Why didn't you list all the other ones? I just don't know.
Because 2/4 is a half, and I'd already listed it. And 2/6 is a third, and I'd already listed it. And 2/12 is a sixth, and I'd already listed it. Now, if you're not that good with fractions, list them all out, and then go back and simplify. And mark them out when you know that you. But see, I really like fractions, and I simplify them in my head as soon as I see them. Most of the time. Which is the same reason why I didn't do 10/12s, because it simplifies, so you don't have to.
I'm pretty sure that the negative side is gonna be -1/4.
It's gonna be negative what?
1/4.
Okay. Okay, so that's what they want us to do. It says, check them. And my drawing wasn't very good because clearly this one was much closer. This one, the right-hand side was much closer to the 1, and the left-hand side, the negative side, was much closer to the axis. So you're probably right. It's probably -1/4. So that's what we will try.
divide by the bottom, multiply by the top, is that right?
Yep, divide by the bottom, multiply by the top. Okay, so I'm gonna use these coefficients and try, what do you guys, we'll start there tomorrow.